Alright guys, welcome back. I hope you guys had a good semester. Some of you guys might not even be watching this video unless you're reviewing, because we're actually doing this one in class. But we're going to start off pretty nice and easy. Basically, we're going to simplify the algebraic fractions and state any domain restrictions. Now, the first thing I want to talk about is domain restrictions. Basically, it means what are the values of x that make the fraction undefined. Okay, those are the values that we cannot have. So, well, in this situation, whenever you have a fraction, the key is that we can never have a zero on the bottom of a fraction. So with all these problems, what you should do is factor it first. So the first one, I'm going to factor the top and the bottom. And this is x plus 4 and x plus 1. And the bottom becomes x plus 4 and x minus 4. So, looking at that, my domain restrictions, I'm going to do that first. In fact, it's probably better before you cancel anything out to do your domain restrictions, because before you cancel it out, you might forget them. X is all numbers, but x cannot be 4 or negative 4. Because if I have a 4 on the bottom, I get a 0, or a negative 4 on the bottom, I get a 0, which is bad. We don't want that. So, last step, just simplify it. These will cross out. We will learn later that that will form a hole in the graph, and our final answer is what's left over. So my final answer is x plus 1 over x minus 4. And that's my answer. Okay? Now, number 2, there's one thing we need to talk about before we do number 2, is we do not like our x values being negative or in the back. So the first thing you should always do is switch it so it flips back towards the front. In order to switch these signs around, we have to pull a negative out. So I'm going to do that over here. Negative, and then this becomes x squared minus 25 over x minus 5. Okay. You should be able to tell me that the domain restriction in this case is all x values such that x cannot be 5. And again, this came from the bottom of the fraction. We cannot have a 0 on the bottom of a fraction. So we cannot have 5. Now I'm going to factor and solve this. By factoring, you get negative x plus 5, x minus 5 over x minus 5. And we can cancel these out. So our answer is negative x plus 5. And leave it like that. I'll leave the negative outside. That's good. Leave it in factored form. Okay, so that is the simplified fraction and our domain restriction based on the denominator. Alright, last two. These are a little bit bigger. We can't even see what our domain restriction is here. You might want to reorder this. It's in the incorrect order right now. And then we'll go from there. We can pull an x out. And then on the top it looks like we can group. So on the top we can group, and we would get an x squared times x minus 2 minus 9 times x minus 2 over, when we pull an x out, actually we could pull a 2x out and reorder it, 2x, and when we reorder this we get, this becomes x to the 4th, this becomes a minus 7x squared, and this becomes a plus 12. Now we can factor this again, and also factor the top. We get on the top x squared minus 9, x minus 2. The bottom becomes 2x, x squared, and then 3 and 4. So x squared minus 3 and x squared minus 4. Okay. Right away, we can get some domain restrictions here. And we can't really simplify. We can simplify a little bit we have to factor the bottom and the top first. So let's do that. Factor it all the way just to see what we have. We have x plus 3, x minus 3, and an x minus 2, all over a 2x, an x squared minus 3, and then this becomes x plus 2, x minus 2. Alright, so first off, I'm going to write the domain restriction here. My domain restriction is that x cannot be a lot of things. Can't be 0 because of this x out here. It can't be 2. It can't be negative 2. Now, you also have to look at this piece here. If you set that piece equal to 0, I'm going to do that down here real fast. X squared minus 3 equals 0. X squared equals 3. X is plus or minus root 3. Okay, so that means that if you have plus or minus root 3, those are also things that will make the bottom 0. We do not want that. So these are all our domain restrictions. Okay, and finally, we just simplify the fraction. I'll write it down here. We have x plus 3, x minus 3 over 2x, x squared minus 3, and x plus 2. And that is our simplified fraction. We can't do anything else with it. And that is where we end with that one. Last one. Again, we want the highest power to be in front, so we need to change the x to the fourth to positive, and we also want to pull out a negative down here too. So I'm going to do that first. I'm going to pull out a negative up here, and I'm going to pull out a negative x actually, and reorder this. So this becomes 3x. In fact, let me pull out a negative 3x. Let's pull out a GCF. So I'm going to pull out a negative 3x, and I'm left with x cubed minus 8. Because when you pull the negative 3 out and the x, you multiply it back in, you would get negative 3x to the fourth and a positive 24x. So that's good there. Down here, I'm going to pull out a negative x, and then we are left with x squared plus 2x plus 4. Okay. Now, let's factor this completely. The top you guys should remember from last semester as a difference of cubes. Yes, you do still need to remember that. So we get negative 3x, x minus 2, x squared plus 2x plus 4 all over negative x times x squared plus 2x plus 4. Now, before we simplify this, because you guys should see the things that simplify, we need to figure out our domain restrictions. Now, remember, usually for domain restriction, we talk about real numbers only. Okay? Therefore, you have to check and see if this will give us real numbers. We already know that x can't be 0. So my domain restriction for this one is that x cannot be, or it's all x values under over the real set such that x cannot be 0. And then if you solve this with quadratic formula or look at it on a graph or just do the discriminant, remember b squared minus 4ac, you get a negative 12. That'll give you imaginary numbers, so we are done with the domain restriction. This will give us two imaginary solutions, so that's not part of our domain. And then we cross those out, and our final answer is, we could also cancel out these x's and these negative signs. We're left with 3 times x minus 2 as our final answer. That is the simplified version of that fraction. And that is all. And that is the first video back. And again, we are doing this in class, so you guys probably won't even have watched it, but if you need to go back and look at what we did, there it is.